Good afternoon. Today I'm going to show you how to convert a DXF file into a Gerber file, and specifically we're using a DXF file that came from a non-AutoCAD source. The Gerber file is going to be modified so that it drives a cutting machine. So what you're looking at here is a simple contour. This contour is made up of independent lines, arcs, and even a spline. What we need is actually a continuous outline that follows this path. What we want in our Gerber file is something that starts at one point and goes all the way around continuously. That's why we're going to use Artworks ASM 500, because it has a line linker. When it outputs the data, it will have linked all of these into one boundary, and then it'll output that boundary vertex by vertex. Let's just have a quick look here. You can see that some of the arc radiuses are very small. If you click on it, you'll see the start, end point, and center of the arc radius. You have some other arcs that are really quite large. That's the center, so you can see it's got a very, very large radius, and it only covers a few degrees. It's almost straight. Let's go now to the ASM 500 program and convert this. So ASM 500 has this nice dialog. The first thing we'll do is select the file we want to convert. It's called Cutting Template. Since AutoCAD has no units, it's important that you enter the units, which I know to be millimeters. Okay, and it scanned the file. Now, although it found 12 layers defined, I determined by inspection that only layer 0 has any data on it. So let's configure this so it works for our cutting machine. We'll start with the Gerber settings. This machine expects the Gerber data in millimeters, and it expects a format of 5.1. That means we have 5 places to the left of the decimal point and 1 to the right. So the highest resolution of this machine is 0.1 millimeter. It expects that the leading zeros are suppressed, so we've selected leading. It likes to see character turn line feet. Now, we don't have any text to configure, so we'll skip that and we'll go straight to the translation options. There's a default line D code which we're going to use, and we'll set that to D10. Scale factor 1. These two parameters are important and they can work together. Instead of using arc resolution, because we have such a variety of radiuses in our arcs, we're using something called chord error. I'm setting the chord error to 0.1 millimeter, and what that means is that no matter what the radius of my arc is, the program will generate enough segments to approximate it so that the error is never more than 0.1 millimeter between the perfect arc and the approximation using segments. Now, some of the options, the only option that's really critical in this case is link lines and arcs, because we have independent lines and arcs and we need them to be linked. There's no hatching in this file or dimensions, but if there were, we wouldn't want to see them, so we click that. We also have controls for how accurately we approximate the spline, and I'm using the same rule for the spline. I'm saying use the chord error of 0.1 millimeter path. We don't need this de-embedding. Make sure that's disabled. That's for some other purpose and it won't give you the results you want. We have different kinds of outputs we can produce. These will produce the identical data outputs. The only difference is 274X has some additional data in the header that 274D does not. But since we're going to take the 274D and modify it anyway, this extra information in the header is of no value to us. When that's all done, I click OK, and now I'm going to continue from here, and I'm going to define the apertures. These apertures are like cutting diameters, but since we're cutting with a blade, we're not going to have many apertures. I'll use the default name cutting template.app. It doesn't exist, we'll make it. All we have to define here is this D10 as a round, and let's make it 0.1 millimeter. That's quite tiny. Just save that. That's it. Now we're going to select the layers to process, and as I mentioned, all these layers are empty. So why bother checking them off? Let's just check off layer 1. We don't want the data filled like we are photo plotting it. We want it outlined, and the only D code available for outlining is 10. And I don't want to use the layer name. I want to call it, say, cutting template. And instead of .gerber, I'll call it 274D. And I just click OK. I'm not merging multiple layers into one, so all I need to do is say start translation, and let's have a look at our Gerber data. So this is the Gerber data being viewed in Gerber View, which is part of the translation package. You can see that it looks pretty much like what we saw, but let's zoom in at these arcs and have a look. Let's zoom in here at this arc. If you look carefully, you'll see that it's actually segments. Just for reference, the width of this segment is 0.1 millimeter, and I think if you kind of drew the ideal arc, you'll see that the ideal arc passes through all of these endpoints, and the error is right here in the middle of each segment. So the error there is probably exactly 0.1 millimeter, which is what we told the program was allowed. So it used the minimum number of segments to maintain a 0.1 or less error. You don't get too many tightly spaced segments. For this smaller arc, you can see that we only needed 2 segments to meet our 0.1 millimeter error. The concept is to minimize the number of segments you need to achieve the error you're willing to accept. And you can even click on a vertex, for example. All right, and it shows you where it is. And if I hit the T button, it'll trace forward vertex by vertex. And as we hit the T, you see how it jumps from vertex to vertex. It comes back here. So you can see it's a continuous path all in one direction. There's no jumps along the path. Everything goes from point A to point B to point C. So now let's take a look at the data itself. Here's our file. If we open it with a text editor, the first command says to select aperture D10. The next command says go to this XY coordinate using D02, which means with the pen up. We're going to the starting point of that figure with the pen up. Then every command after that, as you can see, is a D01, which is move with the pen down. And so it moves from point to point to point to point to point to point to point. There is no more pen up because it's one continuous boundary. And eventually we get to the bottom of the file, and that's the end. Now this file will have to be modified because the cutting machine uses M codes instead of D codes, but the essential data, which is this X and this Y data, never changes. So that's it. That's about as complicated as the conversion gets. Thank you very much.